Hello and welcome to the YouTube channel D Creations Resources. We are looking at different concepts, trying to understand them, and for example, we have been talking about relations and functions. These topics are very important for calculus, and usually people encounter them in 11th or 12th standard. But you keep revisiting these concepts, so if anyone wants to revise their basics, again, one can visit such episodes. So we are going to now see, or rather we are going to try to understand that given a relation, we should be able to determine whether it is a function. Now I hope you recall that we had already learned what is a function, and we say that it's a relation where each input corresponds to exactly one output. So if x, y is how the ordered pair is denoted, when I say the ordered pair, I hope that you are able to remember that we have learned this in the earlier episode, that relation is connection between sets, a set of ordered pairs, and each pair connects an element from one set to an element to the other. We had also taken an example here, and we had seen that this has multiple output values for a single input, but a function must have a unique output for each input. So here is an example of a function that we had seen. So it's a specific type of relation. Going back to determining whether it's a certain relation, a function, what steps will you undertake? Well, first of course you have to examine the set of ordered pairs or the equation. You have to look at each ordered pair or the equation that describes the relation. Then you have to check for repeated x values with different y values. And if you find any input that is associated with more than one output, the relation is not a function. So each input has to have exactly one output, and only then it is a function. And if every input leads to a single unique output, basically the relation is a function. So same thing if you apply to the example we had seen earlier. See here, both one is corresponding to A and B, and here you can see that it is a relation, but it is not a function because one has two images, A and B. But if you see the other example here, you see that it's a unique output, so it's a function. Now let us go to some specific examples. So consider there are two sets, set J and set K, and the elements are given here. So J consists of three ordered pairs, 1, 4, 2, 5, 3, 6, and K consists of three ordered pairs again, 4, 4, 4 minus 4, 6, 6. Now here you see these terms, roster form, set builder form. So we had seen them, studied them earlier. If you have forgotten them, please see this episode about comparing roster and set builder form, two ways how a set can be expressed. Alright, coming back. So this is a roster form, and now if you want to express it in terms of a set builder form, you will write it as xy such that y is equal to x plus 3. Very clear, because when x is 1, y is 4, when x is 2, y is 5, and when x is 3, y is 6. Now if you consider this particular set, the next step you do is mapping. So recall the steps that we had spoken about here. We are checking for repeated x values with different y values. So basically we are mapping the elements. So when you map the elements, you see that for each value in corresponding to x, you have a unique y value. Now here it is a function, and there is another way to do it apart from mapping. It's called a vertical line test. So basically you plot the y coordinate against the x coordinate. So the blue line shows you the graph, and if you drop a vertical line anywhere on the graph, if it intersects more than one places, that means it is not a function. But here you can see that wherever you take this red line, it is going to intersect only one point on the graph, which is the blue line. So from the vertical line test also we know that this is a function. What about the relation K? Now Again, relation K can also be written as a set builder form xy such that x is mod of y. So mod of minus 4 is 4, mod of 4 is 4, and mod of 6 is of course 6. Now here if you see, if you try the first method of mapping, you can see that 4 is mapped to 4 and 4 is mapped to minus 4. That means it doesn't have a unique image. There are two values to which it is mapped. So it is not a function. Similarly, if you use the vertical line test, so you see the graph here, the blue line shows the graph. And now if I drop a vertical line here, you can see that it is intersecting at 2 points here. That means the vertical line test has been not working here. It has failed that test. So it is not a function. So set J, the relation J basically is a function. The relation K is not a function. If you have understood this, what is a test to check whether you have understood it? Please solve this. If L is equal to xy such that y is equal to x minus 15, is relation L a function? So L is the relation here. And you can do it either by mapping or you can try the vertical line test. And of course answer is given to you here, but I would suggest that you do it on your own. Pause the video, do it on your own, and then look at the answer. So this is how we check whether any relation is a function. Thank you.